Okay, so now we're going to look at cells of the brain, neurons. We're going to start with the soma, which is the main body you see here. Within the soma lies the nucleus, which basically monitors the end of the neuron here, the dendrites, for any information that may be received. If the nucleus determines that the information is significant enough, it will be sent down the line through to the axon here, just kind of like a bridge. The axon is protected by what's called the myelin sheath, which coats the outside. It protects the axon, and it also helps ensure that the signal fidelity is maintained so that there's no kind of degradation along the way. Finally, the signal will reach the end here at the axon terminals, and the process will essentially start again. As you can see here, the dendrites from another neuron form this little gap here, and once again, if the signal is significant, it will be once again propagated. Okay, so now we're going to look at neurotransmitters. So we'll start with the presynaptic neuron, which in this case, let's say, is releasing serotonin. So the neurotransmitter will come out of these gates, and they will bind to the receptors on the postsynaptic neuron. Eventually, the neurotransmitter will either degrade through a process called diffusion, or alternatively, it can also be reabsorbed into these little gates here, these reuptake channels. So what a selective serotonin reuptake inhibitor does is it binds to these reabsorption gates, meaning the neurotransmitter is unable to be reabsorbed, thereby leading to an increase in the amount of, in this example, serotonin available within the brain.